So in this video, we're going to do another example of a word problem that utilizes matrices to solve. So this example tells us the sum of three integers is 90. Find the integers if the sum of the first two is the third and twice the third is 4 more than the second. So with this problem, we need to be comfortable taking verbal statements and making sure we can translate them into the proper mathematical statements. Ultimately, our goal is to figure out what these integers are. So we need to remember integers are just whole numbers. So we have the sum of three integers is 90. So that tells us we have three different whole numbers that are adding up to equal 90 because we know the word sum implies addition. And anytime we see the word is in a sentence or in a statement like that, we turn that into an equal sign from a mathematical perspective. So this gives us one of our equations. If the sum of three integers is 90, then x plus y plus z equals 90. We are told to find the integers, and then they have that if. So then there's another condition. If the sum of the first two is the third. Well, like we were just discussing, sum implies addition, and the word is always translates into an equal sign. So it's the sum of the first two. So if we take the first two, x and y, so x plus y, is going to be equals, and it equals the third being the third integer, which is z. So if the sum of the first two is the third and twice the third is 4 more than the second. So we have another condition. Twice the third is 4 more than the second. So this might be the trickiest piece to make sure we translate correctly, but we've got twice the third, so twice the third integer, so 2z, is, that's where our equal sign goes, 4 more than the second. So if it's 4 more than, it's 4 bigger than, so 4 plus the second, so 4 plus y. So we have our three equations that we are going to use in this system. Now we want to remember, like we've discussed in the past, if they're not in order, we need to put them in order. So I need to rewrite these so that my constant is on one side, all of my variables are on the other side, and they're in that order of x, then y, then z, and then the constant. So we have to rewrite the second and the third equations. So the first equation is not changing. X plus y plus z equals 90. The second equation, we need to just move z to that left-hand side. So we're going to utilize subtraction to make that happen. So that'll give us x plus y minus z. And then we moved it from the right-hand side. So we don't have anything left over there. So it's equal to 0. And with that last equation, the only piece that needs to move is y. So notice we don't have an x in this equation. And that's okay. We'll just talk about what that means when we set up our matrix shortly. So we're going to have, after we subtract y, negative y plus 2z equals 4. So now these are in the order we need them in to be able to set them up in that augmented matrix and solve. So if we construct our matrix, in that first row we have 1x plus 1y plus 1z equals 90. Our second row, 1x plus 1y minus 1z equals 0. And then that very bottom row, we don't have an x, so that is 0x minus 1y plus 2z equals 4. And then separating our constants, we get that augmented matrix. So now, like we've done in the past, we identify that lead entry in the top left position. So we know that we need to get zeros below that. We notice one of those entries, the entry in the very bottom row, is already a 0. So we really just need to focus on that second row. So we need to transform that second row using that operation that we've been practicing with and working with a lot through these problems. So we're going to take our very first row multiply it by a -1, add it to the second row, and that will give us our new second row. So in this operation, the second row is the only row that is changing. So our first row still has the values of 1, 1, 1, and 90. Our second row, we are multiplying by that -1. So -1 plus 1 will give us a 0. -1 plus 1 gives us another 0. -1 minus 1 would give us a -2. And -90 plus 0 gives us a -90. We did not do anything to change that third row, so we get 0, -1, 2, and 4. So at this point, we look at our matrix. We've got that lead entry in the top row. Now we notice if we go down to the next row and over to the right, that's going to take us all the way to this position. However, we notice in the very bottom row, we do have an entry in that middle position. So what we are able to do, if we remember, we've got 3 different row operations that we can utilize. So we actually want to take that second row and that third row and switch them so that this entry right here is sitting in this position. So that's what we're going to do, is just use that operation that allows us to switch rows 2 and 3. So we're going to interchange. We're going to switch row 2 with row 3 to get our new matrix. So that top row, 1, 1, 1, and 90. And then our second and third rows are switching. So we're going to have 0, -1, 2, and 4. And then our bottom row is going to be 0, 0, -2, and -90. And so now that puts that lead entry, like we've discussed when we talked about the main diagonal, it puts it in that position. And so now our goal is going to be to get zeros above and below that entry in the second row. And we already have a 0 below it, so our goal is just getting the 0 above. And we notice in this case that those 2 entries are already opposite signs. So all we have to do is, actually, before we address that, we need to get that entry that's in that second row to be a positive one. So we need to address that first before we worry about getting the zeros above or below. That's my fault for that. My apologies. So taking the second row, we are going to just multiply that entire second row by a value of -1 to turn that entry into that positive one we need before we start searching for those zeros above or below. So we always want to remember that so that we don't get ahead of ourselves. So our top row and our bottom row are not changing. Our top row is going to be 1, 1, 190. Our middle row, we said, is changing because we need that -1 to become positive. So our entries in that row are going to be 0, 1, -2, -4. And then that bottom row is going to remain the same, 0, 0, -2, and -90. So now, this is when we look at those zeros above and below that lead entry. So now they are the same value. So we need to take our second row, multiply it by a -1, and add it to our first row to get the new entries in that top row. We don't have to change anything about the bottom row here. So our new matrix, the top row is changing, but that first entry is still going to be 1. If I do a -1 plus 1, I get 0. This will give me a +2, so +2 plus 1 is 3. And then this will give us a +4, so +4 plus 90 will give us a 94. So all of those are the new entries in our first row. We did not change the second row or the third row. So we have our lead entry in the first row, our lead entry in the second row, and then we go down and to the right to find that lead entry in that very bottom row, which is a -2, but as we've discussed, we need that to become a +1. So we're going to have to take that entire bottom row and multiply it by, in this case, a -1/2. So -1/2 times row 3 is going to become our new row 3. So this will be the only row we change in this step. So our top row is still 1, 0, 3, 94. Our second row is still 0, 1, -2, -4. And that bottom row is going to become 0, 0, 1. And then -90 times -1/2 is going to give us a +45. So we've got our lead entries as 1s. So in this case, we just need to get those zeros above in both of those positions. So we can perform both of those row operations in this step like we've done before. So if we do that, we're going to take that bottom entry, that bottom row, multiply it by -3, and add it to the top row to get our new top row. So our new top row will have entries of 1, 0. We will have a 0 right here. And then we would do -3 times 45 plus 94, which will give us a -41. We also need that 0 to take the place of the -2. So we need to take our bottom row. This time, just multiply it by a +2. So 2 times that bottom row. Add it to the middle row. And that's going to become our new second row to get rid of that -2 that's sitting right there. So we will have entries of 0, 1, 0, and then 2 times 45 minus 4 is going to be 86. We are not changing the bottom row in this step, 0, 0, 1, 45. And so now, if we want to take these equations out of the matrices so that we can interpret them, we would have 1x plus 0y plus 0z equals -41. We would have 0x plus 1y plus 0z equals 86. And we will have 0x plus 0y plus 1z equals 45. So this shows us that x is going to equal -41, y is going to equal 86, and z is going to equal 45. So we did say when we solve, especially in a problem like this, we can check with the conditions that were already established. So just remembering that all three of these numbers have to add up to 90. The first two numbers, x and y, if we add them together, they should equal the third number, which is z. And then if we take the third number, which is z, we double it, it's going to equal what we get if we just take y and add 4 to it. And so we could verify that. We could verify all of those conditions. So we have found our integers. So the three integers are negative 41, positive 86, and positive 45. All right. So that brings us to the end of section 2.2 in looking at working with matrices for our row reduction. It's going to be very important that we get comfortable with these because in the next few sections for the rest of the chapter, we're going to continue to do things with matrices, different operations, different things like that. So we will continue to work with matrices for the rest of this chapter, and that first test that we have is going to focus all on matrices. So if we're having some difficulties, we're having some things we're not understanding, make sure that we ask questions. We come visit during office hours and do all of those things to be proactive with that.